Good afternoon, students. In the last class, we discussed the equation of continuity, right? So that is AB is equals to constant, right? So today we will discuss energy of a liquid. Energy of a liquid or fluid, right? So liquid possesses three types of energies, right? So liquid possesses three types of energies. So in that first one, that is potential energy. Second one, kinetic energy, and the third one, pressure energy, right? So in work power energy also we discussed about the potential energy and kinetic energy. So here also it will be the same, right? So what is potential energy? The energy which is possessed due to its position or due to its height, we call that one as the potential energy, right? So the gravitational potential energy is mgh. So that is already we derived in the work power energy relation. So that is in the solid case. So here also the same will be in fluid, because fluid also having some mass, right? So hence the potential energy, that is P is equals to or U is equals to mgh, right? So same as kinetic energy, the energy which is possessed due to its motion. So here we are discussing on the fluid in motion. So hence the energy which is possessed due to its motion, we call that one as the potential kinetic energy. So here one more extra energy we are going to discuss, that is the pressure energy. So the definition will be same, that is the energy which is possessed due to the pressure of a liquid. So due to the pressure of a liquid, so the energy is possessed, that energy we call as the pressure energy, right? So one by one we will discuss, right? So the first one is potential energy. Right? So potential energy, the energy possessed by the liquid due to its position. Within the bracket, we can also mention height. Right? So the energy possessed by the liquid due to its position, so that energy we call as the potential energy, right? So potential energy P dot E, that is equals to mgh, right? So work power energy ನಾವು already derive ಮಾಡ್ಕೊಂಡಿದ್ದೀವಿ. So potential energy ಅಲ್ಲಿ ಕೂಡ objects moving ಅಲ್ಲಿ ಅಂದ್ರೆ having a mass. So here also the liquid which having the mass, right? So here the energy which is possessed due to its height, that we call as the potential energy. There also the same definition, right? So hence we are getting the same relation. Potential energy is equals to mgh, right? So divide this relation by mass, right? So eradu, that is left hand side and right hand side, both we need to divide by mass or shift m to the LHS. So we write potential energy per unit mass, that is equals to G into H, right? So this we call as potential energy per unit mass. Potential energy per unit mass, that is equals to always constant. So why we are taking like this means potential energy per unit mass ಯಾವಾಗಲೂ constant ಇರುತ್ತೆ. Why? Because G is constant, H is constant. So one particular height ಅಲ್ಲಿ pressure ಏನಿರುತ್ತೆ ನಮಗೆ constant ಇರುತ್ತೆ. So pressure energy, potential energy per unit mass ಕೂಡ ಏನಿರುತ್ತೆ ನಮಗೆ constant ಇರುತ್ತೆ. So that is equals to G into H, right? So this is very important. So ಇದನ್ನ next topical ನಾವು ಯೂಸ್ ಮಾಡ್ಕೊಂತಾ ಇದೀವಿ. So pressure, potential energy per unit mass ಅಂತ ಹೇಳಿದ ತಕ್ಷಣನೇ that value is equals to G into H, right? So definition, the mathematical relation, right? So if we shift the m to the LHS, it goes to the denominator. So potential energy per unit mass, so we call this term as potential energy per unit mass, PE divided by m, that is potential energy per unit mass, that is equals to G into H, where G is acceleration due to gravity and H is the position, or we call that one as the height, right? So this is about potential energy, right? So the next one is kinetic energy. So kinetic energy is the energy possessed by the fluid due to its motion, right? The energy possessed by the fluid or liquid. So in the liquid of the bound, we need to mention the liquid. So potential energy possessed by the liquid due to its motion. So motion of it gains energy. So that energy we call as the kinetic energy, right? So kinetic energy, that is K dot E, that is equals to half m v square. So solids ಅಲ್ಲಿ ಕೂಡ same relation ಇತ್ತು. So objects having a mass which is moving. So here also fluid or liquid which is having some mass that is also in moving. So that we are studying in hydrodynamics. So hence fluid ಏನಾಗಿರುತ್ತೆ ನಮಗೆ moving ಆಗಿರುತ್ತೆ. So hence it gains the energy, that is the kinetic energy. So kinetic energy is equals to half m v square. So same as divide this relation by m. So that becomes kinetic energy per unit mass, that is equals to half v square, right? So right hand side ಅಲ್ಲಿ ಇರೋ ಲೆಫ್ಟ್ ಹ್ಯಾಂಡ್ ಗೆ ಶಿಫ್ಟ್ ಮಾಡಿದ್ರೆ ಇಟ್ ಗೋ ಡಿನಾಮಿನೇಟರ್ ಅಲ್ಲಿ ಹೋಗುತ್ತೆ. So kinetic energy divided by m, that is equals to half v square, right? So kinetic energy per unit mass, that is equals to half v square, right? So this is about the kinetic energy. So potential energy and the kinetic energy similar that in the solids. So solids is ಏನಂತ same wise liquids ಅಲ್ಲಿ ಕೂಡ ಬರುತ್ತೆ because both having the mass, right? So one more, the last one is the pressure energy, right? So again from the definition, the energy possessed by the liquid due to its pressure, so we call that one as the pressure energy. So right, so the last one is pressure energy. The energy possessed by the liquid due to its pressure, right? So now we are going to derive the relation for the pressure energy, right? So kinetic energy ಗೆ ಗೊತ್ತಿತ್ತು half m square, potential energy ಗೆ ಗೊತ್ತಿತ್ತು mgh, right? So here we are going to derive the potential energy. So energy possessed by the liquid due to its pressure, right? So for that consider one vessel. Right. So this is one pressure. So this pressure consists of the fluid or liquid. So vessel ಅಲ್ಲಿ ಏನಿದೆ ನಮಗೆ liquid ಇದೆ, right? So liquid which is having the density rho. So it has some density. So that density taken as rho, right? So one piston of area of cross section A is fitted into the vessel. So ಈ vessel ಗೆ ನಾವು ಏನು ಮಾಡ್ತಾ ಇದ್ವಿ, ಒಂದು piston, that is frictionless piston ನ ಅಟ್ಯಾಚ್ ಮಾಡ್ತಾ ಇದ್ವಿ. So that area of cross section ಏನಿರುತ್ತೆ ನಮಗೆ A ಇರುತ್ತೆ, right? So now apply the force onto the piston. So if piston ಮೇಲೆ ಏನು ಅಪ್ಲೈ ಮಾಡ್ತಾ ಇದ್ವಿ ನಾವು, force apply ಮಾಡ್ತಾ ಇದ್ವಿ, right? So that means we are pushing that piston from right side to left side. So force apply ಮಾಡ್ತಾ ಇದ್ವಿ, area of cross section ಏನಿದೆ A ಇದೆ. So hence the pressure is developed and it acts on to the liquid. So ಈ liquid ಮೇಲೆ ಏನು ಆಕ್ಟ್ ಆಗುತ್ತೆ ನಮಗೆ pressure act ಆಗುತ್ತೆ, right? So that pressure P, that is equals to force which is acting per unit area, right? So force apply ಮಾಡ್ತಾ ಇದೀವಿ, external force acting on unit area of cross section A ಇದೆ. So hence develops the pressure, and that pressure is acting on the liquid. So that is given by P is equals to F by A, right? So external force act ಮಾಡ್ತಾ when the piston ಏನಾಗುತ್ತೆ it starts to move, right? So ಈ piston ಏನಾಗುತ್ತೆ ನಮಗೆ move ಆಗಕ್ಕೆ ಸ್ಟಾರ್ಟ್ ಆಗುತ್ತೆ. So consider it moves some small distance, so that distance is dx, right? So force apply ಮಾಡ್ತಾ ಇದೀವಿ, piston move ಆಗ್ತಾ ಇದೆ, ಎಷ್ಟು distance move ಆಗಿದೆ, small distance, so that distance we taken as dx. So force ಇದೆ, displacement ಇದೆ, then ಏನಾಗುತ್ತೆ ಅಲ್ಲಿ ನಮಗೆ work is done, right? So work done, so small distance move ಆಗಿರೋದ್ರಿಂದ ನಮಗೆ ಸಿಗ್ತಾ ಇರೋ ವರ್ಕ್ ಏನಿರುತ್ತೆ small work done, so that we take on dw, right? So dw is equals to force into displacement, so that is dx. F dx cos theta, so displacement and the force both are in the same direction, so theta 0 irutte, so cos 0 value enagutte 1 agutte. So hence we return dw is equals to f into dx. So from this relation we can write F is equals to P into A, pressure into area. So substitute here, so work done dw is equals to P into A dx, right? So A is the area of cross section and dx is the length. So area and the length, so small change in length is the area is there. So this we can write volume, right? So area into length, that we can return the volume. So dw equals to P into delta V or dV, right? So this work done stores as pressure energy, right? So pressure energy is equals to dw, so that is equals to P into dV, right? So this is the pressure energy, P into dV, right? So pressure energy per unit mass, pressure energy per unit mass, that is equals to, so in relation both LHS ಮತ್ತು RHS ಎರಡು ಟರ್ಮ್ ನಾವು ಯಾವುದರಿಂದ ಡಿವೈಡ್ ಮಾಡಬೇಕು, mass ಇಂದ ಡಿವೈಡ್ ಮಾಡಬೇಕು. So mass ಇಂದ ಡಿವೈಡ್ ಮಾಡಿದ್ರೆ we can write pressure energy per unit mass, that is pressure energy divided by unit mass ನಾವೇನಂತ pressure energy per unit mass, that is equals to P dV divided by m. So ಎರಡು ರಿಲೇಷನ್ ಅಲ್ಲಿ mass ಇಂದ ಡಿವೈಡ್ ಮಾಡಿದೀವಿ. So liquid which having the density, so density is equals to mass by volume, right? So this mass we can replace m, that is equals to rho into v, right? So in this small displacement irodrinda namage sikkiro volume kuda enirutte small irutte, so this m we can write, so m into rho dv. So substitute here, we get P dv, that is equals to rho dv. So numerator dv, denominator dv get cancelled. So pressure per unit mass is equals to P by rho. Pressure per unit mass, that is equals to P divided by rho. So this is one more important relation, right? So ಇದು derivation ಇಲ್ಲ, but we need this relation. So ಈ relation ಬೇಕು ಅಂದ್ರೆ first we need to find the pressure energy. So pressure energy, the energy which is possessed due to its pressure. So initially ಇದು rest ಅಲ್ಲಿ ಇದೆ ಅಂದ್ರೆ pressure create ಆಗಬೇಕು liquid ಮೇಲೆ. So pressure ಯಾವಾಗ create ಆಗುತ್ತೆ ಅಂದ್ರೆ when we apply the external force. So external force apply ಮಾಡಿದಾಗ it changes the displacement. So displacement ಆಗ್ತಿದೆ ಅಂದ್ರೆ work done ಆಗಿದೆ. So that work done stores as the pressure energy, right? So that pressure energy individual agi pressure energy anta kelidre, pressure energy in liquids kelidre pressure into its change in volume. So general agi P into V, right? So pressure energy per unit mass, so ಇಲ್ಲಿ ಎಲ್ಲೂ ನಮಗೆ mass value ಇಲ್ಲ, so hence we need to divide the relation. So ಈ relation ಅಲ್ಲಿ mass na divide ಮಾಡ್ತಾ ಇದೀವಿ. So both LHS and RHS, so LHS ಅಲ್ಲಿ divide ಮಾಡಿರೋದನ್ನ ನಾವು sentence ಅಲ್ಲಿ ಬರೆದ್ರೆ pressure energy per unit mass, so RHS ಅಲ್ಲಿ P dV by m. So replacing this mass in terms of density, So density is equals to mass by volume. So mass is equals to rho into volume, right? So small change in displacement irodinda we need the small volume. So hence m is equals to rho dV. Numerator denominator ಅಲ್ಲಿ small volume cancel ಆಗುತ್ತೆ. So last we get pressure energy per unit mass is equals to pressure divided by density, right? So here potential energy, so pressure energy ಮತ್ತೆ potential energy ಎರಡು p ಅಲ್ಲಿ ಇದೆ. So potential energy ನ p dot e ಅಂತ ಬರುತ್ತೆ, ಇದನ್ನ full sentence ಅಲ್ಲೇ ಬರೀಬೇಕು. So don't confuse. Pressure energy per unit mass, pressure energy per unit mass, that is equals to, sorry, potential energy per unit mass, that is equals to gh, right? So next, kinetic energy per unit mass, that is equals to half v square, right? So pressure energy per unit mass, that is equals to P, that is pressure divided by rho, right? So these are the three important relations, right? So by using these three relations, we are going to discuss the Bernoulli's equation or Bernoulli's theorem. So Bernoulli's theorem depends on these three energy factors, right? So one is potential energy, kinetic energy, and the third one is pressure energy, right? So Bernoulli's theorem ಅರ್ಥ ಆಗಬೇಕು ಅಂದ್ರೆ ಫಸ್ಟ್ ಇದು ಅರ್ಥ ಆಗಿರಬೇಕು ನಮಗೆ. ಸೊ ಇದು ಗೊತ್ತಾಯ್ತು ಅಂದ್ರೆ easily we can define the Bernoulli's theorem, right? So this is about the energy of a liquid. So liquid possesses three types of energy. So one is potential energy, kinetic energy, and the third one is pressure energy. So potential energy how we define? So solids ಅಲ್ಲಿ ಯಾವ ತರ ಡಿಫೈನ್ ಮಾಡಿದ್ವೋ ಇಲ್ಲಿ ಕೂಡ ಅದೇ ತರನೇ ಡಿಫೈನ್ ಮಾಡ್ಕೊಳ್ಳೋದು. The energy possessed due to its position or due to its height, so that type of energy we call as potential energy, and its formula is potential energy is equals to mgh. So potential energy divided by mass, we get g into h, so that we call as the potential energy per unit mass, right? So next, kinetic energy, the energy possessed by the fluid due to its motion, we call that one as the kinetic energy. So kinetic energy per unit mass is half v square. So per unit mass ಅಂದ್ರೆ divided by mass ಇರುತ್ತೆ. So hence ಇಲ್ಲಿ ನಮಗೆ m ಇರೋದಿಲ್ಲ, right? So pressure energy, energy possessed by the liquid due to its pressure, right? So pressure relation, that is pressure into volume. So that gives what? The pressure energy, right? So that is the work done by the fluid, right? So by using these relations, potential energy per unit mass, kinetic energy per unit mass, pressure energy per unit mass, we are going to define the statement, that is Bernoulli's theorem, right? So very important statement. Bernoulli's theorem, right? So very important statement and derivation, right? So statement is, in a streamline incompressible fluid flow, in a streamline incompressible fluid flow, the potential energy kinetic energy and pressure energy per unit mass is remains constant, right? So this is the statement of the Bernoulli's theorem. So statement ತುಂಬಾ simple ಇದೆ. So in a streamline incompressible fluid flow. So ನಾವು ಸ್ಟಡಿ ಮಾಡ್ತಾ ಇರೋದು fluids motion ಅಲ್ಲಿ ಇರೋದ್ರಿಂದ maximum we are considering the streamline flow and the incompressible flow. So fluids move ಆಗ್ತಿದೆ ಅಂದ್ರೆ ಅಲ್ಲಿ ನಮಗೆ streamline ಇರುತ್ತೆ ಜೊತೆಗೆ incompressible. So incompressible means the density always remains the constant and streamline means the velocity at a particular point remains constant. So a particular point ಅಲ್ಲಿ velocity ಏನಿರುತ್ತೆ constant ಇರುತ್ತೆ ಜೊತೆಗೆ fluid flow ದಲ್ಲಿ density ಯಾವಾಗಲೂ ಏನಿರುತ್ತೆ ನಮಗೆ constant ಇರುತ್ತೆ. So ಈ ಕೇಸ್ ನ ಕನ್ಸಿಡರ್ ಮಾಡ್ಕೊಂಡಾಗ fluid which is flowing in a streamline incompressible fluid flow, the sum of, right, the sum of, right, so the sum of potential energy, kinetic energy and pressure energy, right? So the sum of potential energy per unit mass, kinetic energy per unit mass, pressure energy per unit mass always remains constant. So ಈ ಮೂರನ್ನು ಆಡ್ ಮಾಡಿದ್ರೆ so ಇದ್ರದ್ದು ವ್ಯಾಲ್ಯೂ ಯಾವಾಗಲೂ ಏನಿರುತ್ತೆ ನಮಗೆ ಕಾನ್ಸ್ಟೆಂಟ್ ಇರುತ್ತೆ. So that is given by the Bernoulli. So Bernoulli given that statement, right? So mathematically if we write means, so potential energy per unit mass plus kinetic energy per unit mass plus pressure energy per unit mass, that is equals to constant. So simple statement, but condition ಯಾವಾಗ ತಗೋಬೇಕು, in a streamline incompressible. So ಇವೆರಡು ವರ್ಡ್ಸ್ ತುಂಬಾ ಇಂಪಾರ್ಟೆಂಟ್. ಸೊ ಫ್ಲೂಯಿಡ್ ಫ್ಲೋ ಆಗ್ತಿದೆ ಅಂದ್ರೆ ಅಲ್ಲಿ ಯಾವಾಗಲೂ ಏನಿರುತ್ತೆ ನಮಗೆ ಸ್ಟ್ರೀಮ್ಲೈನ್ ಫ್ಲೋ ಇರುತ್ತೆ ಜೊತೆಗೆ incompressible ಅಂದ್ರೆ ಅಲ್ಲಿ ಡೆನ್ಸಿಟಿ ಕೂಡ ಕಾನ್ಸ್ಟೆಂಟ್ ಇರುತ್ತೆ, ರೈಟ್? So in a streamline incompressible fluid flow, the sum of potential energy per unit mass, kinetic energy per unit mass, pressure energy per unit mass, that always remains constant, right? So potential energy per unit mass, that is GH, plus kinetic energy plus unit mass, that is half V square, plus pressure energy per unit mass, that is P by rho, that is equals to constant, right? So denominator ಅಲ್ಲಿ rho ಇದೆ, so multiply the whole equation by rho. So here we get rho GH plus half rho V square plus P, that is equals to density always remains constant, hence we take an incompressible. So density ಏನಿರುತ್ತೆ ನಮಗೆ constant ಇರುತ್ತೆ. So constant into constant replaced by one more constant, so that we can write constant. So this is the mathematical relation for Bernoulli's theorem, right? So tumba important relation, right? So exam ಅಲ್ಲಿ ಸ್ಟೇಟ್ಮೆಂಟ್ ಬರೆದ್ಬಿಟ್ಟು ಈ ರಿಲೇಷನ್ ಬರೆದ್ರೆ ಸಾಕು, ಅಥವಾ ಇದು ಈ ಎರಡರಲ್ಲಿ ಯಾವುದಾದ್ರು ಒಂದು ಮೆನ್ಷನ್ ಮಾಡಿ, ರೈಟ್? ಸೊ ರೈಟ್ ದ Bernoulli's equation ಅಂತ ಕೇಳಿದ್ರೆ only the equation ಕೇಳಿದ್ರೆ you need to write rho gh plus half rho v square plus p, that is equals to constant. So where p is pressure, rho is density of the fluid, and g is the acceleration due to gravity, and h is height, right? So potential energy, kinetic energy, pressure energy, sum of all these three energies always remains constant, right? So the derivation is that now we need to prove this relation, right? So statement ಅಲ್ಲಿ ಹೇಳಿದಂಗೆ the fluid which is flowing, that is streamlined and it is incompressible. So ಎರಡು ಕೇಸ್ ನ ಕನ್ಸಿಡರ್ ಮಾಡಿಕೊಂಡು we are going to derive this relation, right? So ತುಂಬಾ ಇಂಪಾರ್ಟೆಂಟ್ derivation. So ಇದು ಅರ್ಥ ಆಗಬೇಕಂದ್ರೆ ನಮಗೆ ಎನರ್ಜೀಸ್ ಗೊತ್ತಿರಬೇಕು, ರೈಟ್? So to prove the relation, first we need to consider ideal streamline incompressible fluid flowing in a tube of variable area of cross section. So idu first consider ಮಾಡ್ತಾರೆ, right? Consider the case that considering the ideal, that is flow. So fluid flow ಆಗ್ತಾ ಇದೆ. So flow ಆಗ್ತಿರೋ fluid ಅಲ್ಲಿ ಏನೇನು ಇರಬೇಕು ಅಂದ್ರೆ, one, that follow the streamline. So streamline means at each and every point the velocity remains constant ಇರಬೇಕು. Next, in that fluid flow, density at each point remains constant ಇರಬೇಕು. So density ಏನಿರಬೇಕು ನಮಗೆ ಎಲ್ಲಾ ಪಾಯಿಂಟ್ ಅಲ್ಲೂ ಕೂಡ ಕಾನ್ಸ್ಟೆಂಟ್ ಆಗಿರಬೇಕು. Next, that fluid flowing in a tube with variable area of cross section. So variable area of cross section means area of cross section ಏನಿರಬೇಕು ನಮಗೆ variable ಇರಬೇಕು, right? So this one is the first consideration. Next, the second consideration is, let the tube is at various height, right? So that is the second consideration. So second consideration ಅಲ್ಲಿ ಏನಿರಬೇಕು ಅಂದ್ರೆ, ಆ ಟ್ಯೂಬ್ ನಮಗೆ various height ಅಲ್ಲಿ ಇರಬೇಕು. So the same tube will be at the two different heights, right? So these are the two initial consideration. So consideration first ಏನಿರುತ್ತೆ about the fluid. So we consider one fluid, so that fluid follow the streamline incompressible fluid and the tube having the variable area of cross section and the tube is at different height, right? So for that, if we write the diagram, so equation of continuity again draw ಮಾಡ್ಕೊಂಡಿದ್ರು, same diagram, it is at two different heights. So this one is ground. So in ground level in the two different heights are there. So first area of cross section at point A, A1, right? So this is point 1, right? So first point ಅಲ್ಲಿ ನಮಗೆ area of cross section ಏನಿದೆ A1 ಇದೆ. So here we take the second point. So here the area of cross section is A2, right? So first point ಅಲ್ಲಿ height ಎಷ್ಟಿರುತ್ತೆ ಅಂದ್ರೆ h1 from the ground, and so from the second point, from the middle ಇಂದ consider ಮಾಡ್ಕೋಬೇಕು. So diagram ತುಂಬಾ important, neat ಆಗಿ, right? So h2 is the height from the ground. So this is ground, right? So it is to tube ಆಯ್ತು. So tube which having the variable area of cross section, ಒಂದು ಚಿಕ್ಕದಿದೆ ಇನ್ನೊಂದು ದೊಡ್ಡದಿದೆ, right? So now the fluid which is flowing in this tube is streamline. So streamline ಇರೋದ್ರಿಂದ ಎಲ್ಲೂ ಕೂಡ ಯಾವುದೇ fluid flow ಅಲ್ಲಿ ಕೂಡ ಏನಾಗಲ್ಲ ನಮಗೆ intersect ಆಗೋದಿಲ್ಲ, two different streamline flow. So ಇದಿಷ್ಟನ್ನು ನಾವು ಏನಂತ ತಗೊಂತೀವಿ streamline, right? So this is the basic initial consideration. So ಇಲ್ಲಿ ಏನು ನಾವು ಸ್ಟೇಟ್ಮೆಂಟ್ ಅಲ್ಲಿ ಕೊಟ್ಟಿದೀವೋ ಅಷ್ಟು ಸ್ಟೇಟ್ಮೆಂಟ್ ಆ ಡಯಾಗ್ರಾಮ್ ಅಲ್ಲಿ ರೆಪ್ರೆಸೆಂಟ್ ಮಾಡುತ್ತೆ, right? So now fluid which is moving, so that means the force is exerted by the fluid. So force exert ಆಗ್ತಾ ಇದೆ ಅಂದ್ರೆ, so there will be the pressure at 1. So first point ಅಲ್ಲಿ pressure ಆಗ್ತಾ ಇದೆ, so that pressure we take the P1. So P1 is the pressure which is acting at point 1, right? So at point 2, P2 is the pressure which is acting. So pressure now only P2 irutte at point. So in direction represent ಮಾಡ್ತಾ ಇದೆ ಅಂದ್ರೆ, this is not the direction for the pressure. So this is the direction for the force which is acting. So here F1. So pressure is a scalar, it is not a vector. So force which is acting perpendicular to the area of cross section, then we getting the pressure P1. So here P2 indicates means, so pressure at A2 is P2. So here the force which is acting F2, right? So the fluid is moving, hence at point 1 it has velocity, so that velocity is v1. So at 2 it has velocity, so that velocity is v2. So v2 is the velocity at A2 and v1 is the velocity at 1, that is A1 or A2, right? So density constant irutte. So at each and every point the density will remain constant. So adannu mention ಮಾಡ್ಕೊಳ್ಳೋದಾದ್ರೆ rho is the density of the fluid. So within inside somewhere here we can mention, right? So it is to diagram, right? So next, consider, so the fluid particles, some mass is moving, so with small interval of time delta t. So fluid move ಆಗ್ತಾ ಇದೆ from the equation of continuity ಅಲ್ಲಿ ನಾವು ಏನು ಕನ್ಸಿಡರ್ ಮಾಡಿದ್ವು, in a small time the fluid is moving due to the force F1, right? So here we can consider that region. PQ. So it covers the small distance dx, right? So v1 is the velocity at P, right? So same as here also consider one more region. So derivation help agente consider one region, that is R and S. So here also it covers the same distance dx in the same time, that is dt, right? So at P it has the velocity v1 and at R has velocity v2, right? So distance covered by the fluid in time delta t, right? So that is dx is equals to v1 into delta t, right? So velocity is equals to displacement by time, right? So displacement or distance, that is equals to velocity into time. So e region alli namage velocity enirutte v1 irutte, so it covers the distance dx. So hence the distance dx is equals to v1 into delta t, right? So mass flow in the region from P to Q, right? So mass which is flown from the region P to Q, right? So mass enagide nಮಗೆ ಎಷ್ಟು mass move ಆಗ್ತಾ ಇದೆ, right? So that we taken delta m or dm, right? So delta m1, that is equals to volume into density, volume into density, right? So delta m1, that is equals to volume. So volume again area of cross section is a1 into displacement dx, right? So adu length alli act agodilla volume ಏನಂತ ಬರ್ಕೋಬಹುದು a1 into dx into density rho, right? So dx we have the value, so delta m1, that is equals to a1 v1 rho into delta t. All this one is the first relation, right? So mass move of the other, that is because of the force. Due to the force the mass is moving. Due to the force the mass is moving and it covers distance, right? So force is there, distance is there, both are in the same direction, so hence work is done, right? So work done in flow of fluid from P to Q. So initially small region ಅಂತ consider ಮಾಡಿರೋದ್ರಿಂದ work done. So small work done ಆಗುತ್ತೆ, so that work done is dW, right? So all the work done at the region P, we can take that one as W1. So first region ಅಲ್ಲಿ work done ಆಗ್ತಿರೋದ್ರಿಂದ ಅದನ್ನ ಏನಂತ ಕರ್ಕೊಂತೀವಿ W1. So work done W1 is equal to force into displacement, right? So F into the displacement is dx, right? So force, that is pressure into area of cross section a1 into dx, right? So dx is v1 into delta t, right? So work done w1 is equals to p into a1 v1 delta t, right? So this is from this one is postulation. So tumba lengthy derivation is that, right? So this is from first, right? So A1 V1 delta T. So here also A1 V1 delta T. So this term we can replace by delta M by rho, right? So in this two term now we can replace delta M divided by rho. That is the density, right? So W1 that is equals to P into, so A1 V1 delta T. So ಇಲ್ಲಿ A1 V1 delta T. So remaining ಏನಿದೆ rho ಇದೆ. So rho LHS ಆಗುತ್ತೆ. That is delta M1 by rho, right? So W1 that is equals to, so delta M1, so mass in terms of density, right? So density is equals to mass by volume, right? So delta M1 is equals to density into volume. So small mass is in the small volume, right? So W1 is equals to P, in place of delta M1 we can write rho delta V divided by rho. So in the numerator rho, denominator rho get cancelled. So work done W1 is equals to P into delta V. So we call this one is the equation 3, right? So work done, we calculated the work done in moving the fluid from region P to Q. So P in the Q ಗೆ ಎಷ್ಟು ಮೂವ್ ಆಗಿದೆ ಅನ್ನೋದಕ್ಕೆ, so force act ಆಗಿದೆ. So force act ಆಗಿರೋದ್ರಿಂದ displacement ಆಗಿದೆ. So displacement ಆಗಿದೆ ಅಂದ್ರೆ ನಮಗೆ ಅಲ್ಲಿ work done ಸಿಕ್ಕಿದೆ. So ಆ work done ಏನಾಗುತ್ತೆ ನಮಗೆ P into delta V. So V is the change in volume. So ಇಷ್ಟು ಏನು volume ಇದೆ ಅಷ್ಟು. So here the how much mass which is moved here, so the same mass will be moved from the region R to S, right? So similarly directly we can write, so work done in flow of fluid from region R to S. So R in the S ಗೆ ಎಷ್ಟು fluid move ಆಗಿದೆ, so the same fluid mass will move from P to Q, right? So that work done is at point 2. So second point ಅಲ್ಲಿ ಇರೋದ್ರಿಂದ work done W2 that is equal to P into delta V. So here is P1. So P2 delta V. So same amount ಏನಾಗಿದೆ ನಮಗೆ ಮೂವ್ ಆಗಿದೆ, right? So next, total work done. So here work done at region 1 and work done at region 2. So ಎರಡು at a time ಆಗೋದ್ರಿಂದ total work done that is W is equals to W1 minus W2, right? So W is equals to W1 is P1 delta V minus P2 delta V. So ಎರಡು ಟರ್ಮ್ ಅಲ್ಲೂ ನಮಗೆ delta V ಕಾಮನ್ ಇದೆ. So P1 minus P2 into delta V, right? So this work done, some part of this work done is used as the kinetic energy and some part of this work done is used as potential energy, right? So some part of this work done is used as change in potential energy and some part is used as change in kinetic energy, right? So ಇಲ್ಲಿ ಬಂದಿರೋ ಟೋಟಲ್ ವರ್ಕ್ ಡನ್ ಅಲ್ಲಿ ಸಮ್ ಪಾರ್ಟ್ ಆಫ್ ದ ವರ್ಕ್ ಡನ್ ಪೊಟೆನ್ಷಿಯಲ್ ಎನರ್ಜಿ ಆಗಿ ಯುಟಿಲೈಸ್ ಆಗ್ತಾ ಇದೆ. ಸೊ ಸಮ್ ಪಾರ್ಟ್ ಆಫ್ ದ ವರ್ಕ್ ಡನ್ kinetic energy ಆಗಿ ಯುಟಿಲೈಸ್ ಆಗ್ತಾ ಇದೆ, right? So from that we can write W is equals to, that is change in potential energy. So change in potential energy is delta P dot E. So delta represents small change, right? So plus delta kinetic energy. So change in kinetic energy, right? So now we need to find the values of delta PE and delta kinetic energy, that is K dot E, right? So change direct. First we need to find the potential energy at point 1. So the relation is to the fifth relation, right? So potential energy definition ಏನಂದ್ರೆ the energy possessed due to its position. So first point ಅಲ್ಲಿ ಎಷ್ಟು position ಅಲ್ಲಿ ಇದೆ, ಎಷ್ಟು height ಅಲ್ಲಿ ಇದೆ, h1 height ಅಲ್ಲಿ ಇದೆ. So potential energy PE1, that is equals to mgh1, right? So similarly potential energy at point 2. So ಈ second point ಬೇರೆ height ಅಲ್ಲಿ ಇದೆ, that is at a height h2, hence potential energy at 2, that is PE2, that is equals to mgh2, right? So this is the potential energy at 1, potential energy at 2, right? So change in potential energy, right? That is delta PE, that is equals to mgh2 minus mgh1, right? So delta potential energy, that is equals to m into g common h2 minus h1, right? So mass in terms of density, so mass na ಏನು ಬರಿಬಹುದು rho into v, right? So change in potential energy, that is equals to rho g delta v into h2 minus h1, call this one as the sixth relation, right? So ನಮಗೆ ಏನು ಸಿಕ್ತು, change in potential energy ಸಿಕ್ಕಿದೆ. ಆಲ್ರೆಡಿ ಇಲ್ಲಿ ನಮಗೆ ವರ್ಕ್ ಡನ್ ಸಿಕ್ಕಿದೆ. So that work done is utilized as change in potential energy, right? So that is rho g delta v into h2 minus h1, right? So next, so practice ಮಾಡಬೇಕಾದ್ರೆ ಕೆಲವು ಸ್ಟೆಪ್ಸ್ ನ ಡೈರೆಕ್ಟ್ ಆಗಿ ಬರೀಬಹುದು, ಬಟ್ ಇಲ್ಲಿ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡಿಂಗ್ ಪರ್ಪಸ್ ಗೆ ಈಚ್ ಅಂಡ್ ಎವ್ರಿ ಸ್ಟೆಪ್ ನ ಬರಿತಾ ಇದ್ದೀನಿ, ರೈಟ್? ಸೊ ನೆಕ್ಸ್ಟ್ kinetic energy at point 1, right? So the fluid is moving with velocity v1. So at point 1 ಅಲ್ಲಿ kinetic energy ಏನಿರುತ್ತೆ ನಮಗೆ k dot e1, kinetic energy 1, that is equals to half m v1 square. So first point ಅಲ್ಲಿ velocity v1 ಇರುತ್ತೆ, so half m v1 square. So similarly kinetic energy at the point 2, that is kinetic energy 2 is equals to half m v2 square, right? That is the potential energy at second point, right? So next, change in kinetic energy. So change nothing but difference, right? So change in kinetic energy, that is delta Ke, that is equals to half m v2 square minus half m v1 square, right? So difference. So change in kinetic energy, that is equals to, in both we can take half m common, so remaining v2 square minus v1 square. So replace mass by density rho into delta v, that is v2 square minus v1. So mass at point A ನಲ್ಲಿ ಎಷ್ಟು ಮೂವ್ ಆಗುತ್ತೋ the same mass will move at 2. So ಎರಡರಲ್ಲೂ ಕೂಡ ಸೇಮ್ ಮಾಸ್ ಮೂವ್ ಆಗೋದ್ರಿಂದ m1 ಮತ್ತೆ m2 ಕನ್ಸಿಡರ್ ಮಾಡಿದ್ರೆ ಡೈರೆಕ್ಟ್ಲಿ take m, right? So mass is equals to rho into delta v. So this gives what? Change in kinetic energy. Call this one seventh relation, right? So work done. So work done is equals to change in potential energy plus change in kinetic energy. So ನಮಗೆ change in potential energy ಸಿಕ್ತು, ಜೊತೆಗೆ change in kinetic energy. Now substitute equation 6 and 7 in 5, right? So work done with P1 minus P2 into delta V, that is equals to change in potential energy rho G delta V H2 minus H1 plus kinetic energy of rho delta V V2 square minus V1 square. So confuse agadi, delta V andre change in volume, V2 ಮತ್ತೆ V1 andre velocities, right? So in both LHS ಮತ್ತೆ RHS common term ಯಾವುದು ನಮಗೆ change in volume, that is delta V. So ಎಲ್ಲ ಕಡೆಗೂ delta V ಏನಾಗುತ್ತೆ ನಮಗೆ cancel ಆಗುತ್ತೆ, right? So now we can write this one P1 minus P2, that is equals to rho G H2 minus rho G H1. So rho G na we can multiply ಮಾಡಿ ಬರಿಬೇಕು, right? So same as here also half rho V2 square minus half rho V1 square, right? So now shift minus comes to the LHS. So we get P1 minus LHS ke shift padre plus rho G H1 plus half rho V1 square, right? That is equals to, so P2 shift to RHS minus becomes plus, that is P2 plus rho G H2 plus half rho V2 square, right? So this is pressure energy at point 1, potential energy at point 1 and kinetic energy at point 1. So sum of pressure energy, potential energy and kinetic energy at point 1 is equals to sum of the pressure energy at point 2, potential energy at point 2 and the kinetic energy at point 2, right? So in general we can write P plus rho G H plus half rho V square, right? So that is equals to constant, right? So this is the final expression for Bernoulli's theorem. So remaining we will continue in our next class.